Hey guys, here we go. We're starting Unit 2. So this 2.1, limit definition of the derivative, an alternate form of the limit definition. Okay, so eventually I will show you little tricks to find derivatives. But of course, there's a longer way on how to do derivatives, and that's dealing with the definition. We do have to learn the longer way because sometimes it shows up in multiple choice and based on the steps. So we've kind of done a little bit of this before, as you can see, the x plus change of x, because that's when we were substituting in to simplifying stuff. But this time we're really going to look at that limit. So instead of approximating the instantaneous rate of change. So remember that instantaneous rate of change is the slope at a specific point. We frequently deal with the slope of a curve. So last chapter, when we were doing the slope at a certain point, really if it was on a line, well, luckily for us, the slope of a linear equation is the same at any point. So that's very easy. But once we do it on the curve, it changes depending on where we're at any given point, right? So the idea is that we're trying to find the line that is tangent to that curve, okay? Tangent to that curve. So as you can see right here, they have this curve right here. A secant line would be going through 2 points, where the tangent line of it only goes through 1 point right here. So let me highlight that for you if I can. So the tangent line is only hitting that curve at one single point, okay? Now, what are we going to do? Well, the slope of the tangent line is what we call the derivative, okay? So the slope of this tangent line is called the derivative. The most common symbol for derivative is f prime x. That's what we call it, prime, okay? There are some other notations that we will encounter a little bit later, but if we wanted to look at those now, it would be f prime of x is what we'll normally use. Y prime comes in later, dy over dx, or d over dx of f of x. So these all mean the same thing, derivative. Now, what we're going to start with is the definition of derivative, which is actually the limit as x approaches 0, the change of x approaches 0. So that way we're getting closer and closer and closer to that one tangent line. Okay, so it's like taking all those secant lines and getting closer and closer to that tangent line. Now, I know that when we did a problem like this earlier in Unit 0, it was very confusing using that change of x to know that these two were different. So right away, guys, I'm going to change it to h. So at least that we know what we're dealing with, okay? So down below, we have f of x equals x squared plus 2, okay? So let me read some definitions for you. A vertical tangent line has no slope. So vertical line, right? Vertical line has no slope. So a curve that has no derivative at any point where it has a vertical tangent line, okay? So if we can make a vertical line, there is no derivative. Differentiation is the process of finding derivatives, okay? If a derivative exists at a point on a curve, the function is said to be differentiable, okay? Let me actually summarize that. If we can find a tangent line that has a slope that is not a vertical tangent line, because remember that vertical tangent line has an undefined slope. So if we have any tangent line that has a slope, okay, to a curve there, it is said that it is differentiable, okay? We can differentiate it. It has a derivative. You see all those there? Now, that's if it exists. If the derivative does not exist, It is not differentiable. It doesn't have a derivative. That slope is undefined, or you'll find out in other cases what can't be differentiable later, okay? Now, let's practice the definition. The definition is just putting it in as f of x plus h minus f of x over h, simplifying it, and then saying as h approaches 0, what do we get? What value do we get? Okay, so that's what we're going to do right now. So we're finding the derivative, so f prime of x. So f prime of x equals the limit as the change of x goes to 0. But what did I say we were going to do to make this easier? We were going to make it as h approaches 0. So we're going to use the h, not the change of x, so it doesn't confuse us. So the first thing I'm going to do is look at f of x plus h. That means we're putting in x plus h for every x we see in our f of x function. So I have x plus h squared plus 2. That is just this first part right here in our function. Now we're going to subtract our original function. Do not forget parentheses. Our original function is x squared plus 2. Okay, very important, those parentheses. Maybe you give yourself a note. Don't forget parentheses, okay? All over h. Now, of course, if we looked at this right now and we plugged in 0, we would have a number over 0, which we know is undefined. We can't deal with that. So I need you to simplify first, okay? Next trick part of it is this x plus h squared. You need to remember that you need to FOIL that. Now, when we keep going, we want to say equals. We're still writing that limit symbol because we haven't taken the limit yet. We're simplifying our f prime there, okay? So if I FOIL that, I get x squared plus 2xh plus h squared, okay? Now we have this plus 2 right there. I'm going to distribute the negative out, so negative x squared minus 2 all over h. Okay, let's see what we can get rid of. Well, the 2's cancel. The x squareds cancel. So let's see what we have left. We have limit as h approaches 0. And if you look, we have 2xh plus h squared all over h. What do you think we can do next? Well, we can factor in h, guys, because what's great about factoring on h here is we have h times 2x plus h all over h. What happens between h and h? Well, h over h is 1, so it's almost as if it's no longer there. It cancels out, right? Now, if we plug in 0 for x, so we're going to take that limit, then we have the value of, if that goes to 0, we're left with 2x. So the derivative of this function is 2x. Okay, now what does that mean? That helps us find the slope of the tangent line to any point on this curve. Okay, so what this question is asking, when it says f prime of negative 3, what it's actually asking is find the slope to the tangent line at the point -3, okay? So when we have this curve, that parabola at -3, at x is -3, we're going to be able to find the slope of that tangent line. Now, because we found the derivative, all we have to now do is plug in -3 and solve. So the slope of the tangent line at -3 is going to be 6. All right, so let's do it again. And of course, every time we do more than one example, it's going to get more difficult along the way. So be careful with your square roots here. Okay, so guys, this is still f prime of x, but because they used the value of y here, they didn't say f prime of x, they said y prime. So it's just getting you used to the notation that it can go back and forth, okay? So it's still taking the derivative, okay? We're going to take the derivative by the definition of derivative, okay? So I'm gonna write that definition up here again. Remember, it's limit as x approaches, or not x, h approaches, sorry guys. H approaches 0 of f of x plus h minus f of x all over h, okay? So I just wrote that up there like on the other page so you don't have to go back and forth. So what we have now is limit as h approaches 0. So we're going to go x plus h. We're going to put that in for every x we see. So square root of x plus h, so that's that first part, minus our original, which is square root of x, all over h. We did something like this in unit 0. Our problem right now is our square roots. We need to get rid of that. The best way to get rid of it, and I'm going to change colors so you can see, is to multiply by the conjugate. Okay, so we keep the first one the same, but we're going to do the opposite. So in this case, add the second. Okay, that is the conjugate. Whatever we do to the bottom, we must do to the top because we're not changing the value, we're changing how it looks. So really, we're multiplying by the value of 1, right? Something over itself is 1. All right, so on top, so equals, I'm not taking the limit yet, so I'm still going to write limit down. So on top there, I could FOIL, but remember, this is almost like the difference of squares. In other words, what's going to cancel is that middle term. So really, the square root of x plus h times the square root of x plus h is x plus h. A negative times a positive is a negative, and x, square root of x times square root of x is just x. Now on the bottom, I'm not going to distribute or anything. I'm just going to write down what I see. All right, now what else can we do? If you look, guys, we can cancel out the x's. That's nice. And then if we look, I'm going to say limit as h approaches 0. But really here, before I write down what I'm going to write down next, if we have an h on top and an h on the bottom, again, what happens? Well, h over h is 1, so it's like those two cancel. Be very careful what's in the numerator. If there's nothing there, it's not 0, it's the value of 1. So I have 1 over the square root of x plus h plus the square root of x. Okay. Now we know that h is going to 0. So what does that leave us? Well, when I plug in 0 there, it leaves us with 1 over square root of x plus the square root of x. Now you're adding, guys. So if you're adding a square root of x plus the square root of x, you get 2 square root of x. So the derivative of square root of x is 1 over 2 square root of x. All right. Again, they're giving it as a different form, dy over dt. They say dt instead of dx in this case because they're using t as a variable and not the x, okay? So sometimes they trick you on that stuff. dy over dt is the same as f prime of t. So in other words, instead of x's up here, guys, we see t's. All right, so I have to put down limit as h approaches 0. And then remember we do t plus h first. So anytime I see a t, I'm going to replace it with a t plus h. Because that's in my start of my limit definition. Then I subtract the original, which is 2 over t, all over h. Be careful how much you're writing, guys. So I'm going to start writing across because we have to do some algebra here. Okay, now what I want to tell you, you must look at is that on the numerator there we have 2 fractions. When we subtract fractions, what do they need to have in common? They need to have a common denominator. So we're missing a t on this side, so I'm going to do this in a different color so you can see. I'm missing a t on this side, and I'm missing a t plus h on this side. Okay, so it's like multiplying by the denominators. All right, that leaves me on top 2t minus 2 times t plus h all over that common denominator of t times t plus h. Remember, that was all over h. All right, now we have to do some algebra, okay? Let me do my arrow. So I have limit as h approaches 0. Now, remember that, first of all, I'm going to do that distributing right there, right? So I'm going to say 2t minus 2t minus 2h. Remember, it's minus because we're distributing the negative 2 out. All over t times t plus h. Now, dividing by a fraction, and h is h over 1, dividing by a fraction is the same thing as multiplying by its reciprocal. So this is like multiplying by 1 over h. Okay. Now, those two cancel. And if you look, we're going to put this together. So we have a limit as h approaches 0 of negative 2h over h times t plus h. Those h's cancel, right? And then when we plug in 0, so this h here goes to 0, what are we left with? We are left with negative 2 in the numerator, and t times t is t squared. So we took the derivative of 2 over t and got negative 2 over t squared. Okay. All right, alternate form. Now, alternate form gives the value of the derivative at a single point. So up here, when we were finding the derivative, we were finding the equation of any an equation that we could plug in any point and get the slope of that tangent line. Okay, so this is our general derivative. But the truth is, if we know what point we want already, we can use the alternate form of the limit definition, which in this case is f of x minus f of c, all over x minus c. Okay, now could we use the limit definition of that f of x plus h minus f of x all over h? Yes, we could. We could do that, come up with an equation, and then plug in the 3. Or we can skip all that work and do the alternate form, okay? So let me put this in the correct. So my c is going to be 3. All right? So right here we have a limit as x approaches c, which in this case is going to be 3. Then I put my f of x down minus f of 3. So I'm just going to put f of 3 right now, and then I'm going to show you how that looks, okay? All over x minus 3. Okay, so what I'm going to do right now is evaluate that f of 3. So I get limit as x approaches 3 of x cubed minus, well, if I plug in 3 for x here, 3 cubed is 27 all over x minus 3. All right, here's where you have to do some either long division, synthetic division, or memorize your cubic stuff, okay? But if you do long division, don't forget your 0 pieces, right? So I would have x minus 3 divided by 1x cubed plus 0x squared plus 0x minus 27. Okay? You guys go through all that, but I'm going to give you the answer right now. We get limit as x approaches 3. We get x minus 3 times x squared plus 3x plus 9. All over, because that's factoring that out, x minus 3. Now what happens, guys? Well, x minus 3 cancels, right? And then when we plug in, we're looking at 3 squared plus 3 times 3 plus 9, which equals 27. So the slope of the tangent line at 3 is 27. All right, guys. Now, there's not too much examples for this because it's going to be work. Watch your algebra. This is all about algebra. Take your time and look at key points that you're missing. Don't forget to FOIL. Distribute that negative. Conjugate pairs to be able to eliminate things. All right, keep going. Ask me questions whenever you have any of them. Bye, guys.